Hello and welcome to our webinar, Improving Indoor Air Quality with KNX. The webinar is live from our new studio and we are very happy that you are here today. A few quick notes before we start. If you have some questions, then you can use the chat function. You find it on the top and you can send us the questions and we will make a stop and answer you the questions during the webinar. The webinar is recording and so all from you will get recorded afterwards the webinar. My name is Frederik Riedel. I work as a head and trainer at the technical service at Elsen Electronic and I'm your contact for all questions about our products.
Okay, and I'm Martin Speer and I'm delighted to be here today. As a product manager, I deal with the requirements for our products on a daily basis. And as the interface to almost all parts of the company, I know the needs, advantages and disadvantages of our products. And as a long-standing system integrator, I am particularly familiar with the user perspective from practical experience.
Okay, here's a quick look to our agenda so that you know what to expect. We start with the air quality foundations. Then the next topic is about the difference from the CO2 and VOC. Then we have a look at the areas of application for air quality sensors. Then we have a short product presentation. Then we look how we can install the devices. And then we have a look in the parameters of the Cala IL CO2. And the last topic, it's about the application examples. In the next section, we will look at the basics of air quality. Air quality describes how clean or polluted the air we breathe is. Temperature, humidity and wind play a role as they influence the spread of pollutants. Why is air quality so important? The CO2 content in the air influences general well-being. Poor air quality can put a strain on the respiratory tract, heart and circulation. In conclusion, we can say good air quality maintains health, increases well-being and reduces the risk of illness.
Okay, now we come to the difference between CO2 and VOC. Let's start with the carbon dioxide CO2. CO2 is a colorless and odorless gas produced naturally by respiration, combustion and industrial processes. CO2 indicates how much breathing air has already been used. The higher the CO2 value, the less oxygen is available in the room. CO2 is not a pollutant in the classic sense, but harmful for health in high concentrations, for example, fatigue, lack of concentration and so on. And important, it's a direct indicator of indoor air quality as it is strongly related to fresh air supply. Now we come to the volatile organic compounds, VOC. The most common units here are ppm, that means parts per million. ppm describes the volume fraction of VOCs in the air. The next unit is milligrams per cubic meter of air. It describes the mass of VOCs per air volume. VOCs are a large group of substances consisting of gaseous organic compounds, for example solvents, fragrances and plasticifiers. They arise from furniture, paints, cleaning agents, adhesives or tobacco smoke. Many VOCs have an irritant, allergenic or even carcinogenic effect. There's no direct correlation with fresh air content, but with emissions from materials and products. Particularly relevant emissions for VOC sensors are aromatic solvents, toluene, xylene, styrene and so on. They come from paints, varnishes, plastics, and they can cause headaches, fatigue and irritations. And the next thing is ketones and esters, for example acetone and so on. It's typical solvent odor, it's highly volatile and causes short-term heavy pollution of indoor air. Then the next thing is alcohols, ethanol, butanol and so on, often found in cleaning products. High concentrations irritate here the respiratory tract. And the last thing is terpene, for example from wood, resins, cleaners. They have a pleasant smell, but they can form irritating secondary substances in combination with ozone. Okay, a little summary. CO2 shows that oxygen has been consumed by living organisms, and VOC shows the chemical air pollution caused by substances in the environment. So many harmful emissions, especially from paints, varnishes and new furniture, are difficult to assess with the human sense of smell. A VOC sensor measures the total concentration, and reliability indicates when the air quality becomes critical. VOC is often used as a substitute parameter because it can capture many pollutants and odors, for example in the kitchen, the cellar or toilet. However, CO2 is the better measured variable for fresh air assessment in the room, as it directly reflects the load from exhaled air. Okay, now we come to the areas of application for air quality sensors. First thing, CO2 sensors usually measure the carbon dioxide concentration in ppm, as mentioned before. CO2 sensors indicate when ventilation is needed for better concentration and less fatigue. CO2 are for measurement of VOCs, early detection of pollutants and odors from furniture, paints, candles or cooking. And the targeted CO2 measurement enables automatic control of ventilation systems and air purifiers. A quick overview about the areas of applications where we can use the air quality sensors, for example in offices, as you can guess, hotel rooms, classrooms, meeting rooms, of course, event rooms, kindergartens. We will have a closer look later. Okay, at this point, do you have any questions about CO2 or VOC? Just write a comment in the chat in the webinar. Okay, there's a good commentar in the chat. It says, good air quality is very important for children and old people, especially during cold months. Right. No more words to add here. Okay, yes, there are no other comments, so, oh no, there's one. There's a good question. How many months do we need to replace those sensors? Frederick, what would you say?
I think the CO2 sensors not have to be changed because they all of our sensors have an automatic calibration integrated, so they make their own calibration, and so it should work for long years.
Yes, the sensors never get dirty, so you can have them for many years. Okay, we can't find any questions, so let's getting forward. Okay, the first thing was we're talking about CO2 and VOC, and now we come to the components we have. Okay, the first thing is our Cala KNX IL with CO2 and without CO2. I will show it in the camera. Okay, as you can see here, this is our Cala IL. And the good thing is it's a traffic light. It has a traffic light function for visualizing statuses. We are going closer to it in the next slides. And it has a display that shows one of the colors green, yellow or red. And there are two variants, one with CO2 measurement and control of CO2 concentration in the air. Okay, the next thing is our KNX AQS TH UPGL. Okay, so you can see it looks like the Cala EL but without a display. So it's no traffic light function. But it can measure the CO2 temperature and humidity. For example, in office buildings or schools, it's very, very good without any touch buttons. So it has a calculation of the dew point and PI control is integrated. The next thing is our KNX VOC THUP touch. It looks like this in black and white. It's for measurement of mixed gas temperature and humidity. It has an integrated PI control and displays 1, 2, 3 lines. And it has 2 touch buttons. We are going closer in the next slides. The fourth product is our CEVI KNX AQS THD LPR. You can see it here. We have it in white and black as well. As you can guess, it's for the ceiling mount and it has a measurement of brightness, CO2, temperature, humidity and air pressure. And of course it has the presence of persons in it and the PI control. Okay, now we go closer to the products. So as I showed before, the Cala KNX IL with CO2 and without CO2. CO2 traffic light for displaying the air quality via 3 colors, red, yellow, green, illuminated or flashing. You can change it in the ETS parameters. And we are going closer to this when we show you the parameters in a few minutes. We have integrated CO2 threshold values, integrated CO2 PI control, for and OR logic gates, and 2 variable comparators. Okay, the next thing is, as mentioned, oh no, sorry, it's the same product, but it's for the Swiss installation systems. Now the next product, our KNX AQS THUP GL. It measures the CO2 as well, and the temperature humidity calculates the dew points. There are adjustable threshold values and all logic control variable comparators. And the PI controller is integrated for ventilation, heating, cooling, and it has a comfort warning in accordance with the DIN 1946. It fits into standard switch frames. And as the Cala EL as well, it's also available for Swiss installation systems. Okay, now our KNX VOC THUP touch with the display in the middle. It measures the VOC, temperature, humidity, and it calculates the dew point. It has 2 touch buttons for set points modes, but also freely programmable. So you can use it for opening and closing windows manually if you don't only want it to be automatic controlled. And the display is for measurement and bus data. It's parameterizable via ETS. It has adjustable threshold values and an OR logic and control variable comparator. And as the product before, a PI controller is integrated. And of course, as you know, our products, most of them are also available for Swiss installation systems. Just have a look at our website and you can see it, which products are for Swiss installation systems. Okay, last but not least is our CEVI KNX. It detects presence, controls light via brightness, threshold value. And of course it measures CO2, temperature, humidity, air pressure, and it calculates the dew point. So very multifunctional. Has adjustable limit values and all logic, multifunction modules and manipulated variables comparators. of course, PI controller is integrated. Okay, at this point, do you have any questions? Just write in the comments, please.
Here is one question, and the question is where you recommend to install the CO2 and VOC sensors in relation to the bottom of the room. I think Martin can answer this.
So the best thing is to have it on 140 centimeters from the bottom, so it's nearly in the middle of the room, and there are the best measurement values. But it's also recommended, our SEBI, for example, is to install on the ceiling, and that's no problem as well. But your question is regarding what's the best installation method, so it's 140 centimeters from the bottom. Thank you for the question.
Okay, then we go to the next topic. The topic it's about mounting. All the devices in the Cala series are installed in the Corley, and I show this to you by the Cala EL. Here you see the first picture. By the first picture it's the backside of the Cala EL. On the top you found the number 1, it's the KNX connector. Then the number 2, it's the programming button. With this button you can set the device in the programming mode. And by the number 3 you see the KNX programming LED. The number 4 is the clamp, and with the clamp you fix the device in the frame. Then in the second picture you see the installed device inside the electronic box. You see the diameters of the device in the box, and the box is mounted in the wall. In the third picture you see the Cala EL, and you see with the number 1 the frame. The frame it's the 55 to 55 millimeter frame. It's a standard frame and you can use it from different companies. And the number 2 shows the openings from the device for the air circulation that we can measure inside the measurement values for CO2. And in the last picture you see the frames. The frames should show us that it's not allowed to install the Cala EL in the same box, electrician box, as the 230 volt. If you want to install next to the frames the 230 volt, then you have to have a distance between both frames from as a minimum 4 millimeters next to the other frame. So, and the next what I want to show, it's the live installation, how we can install this device in a box.
And to this topic, there's a question from Gian Domenico. He says, what is required to install the CO2 sensors or the sensors? Only a KNX port, and that's the right time, because now Frederick shows it. You only need KNX. I think you're heading, or the question is about, do you need additional 24 volts or something like that? But Frederick is showing it here.
Okay, then we change to the camera. Okay. So you see the open box in the wall. It's prepared with the KNX connection, and the first what we have to do is to install this metal frame. I put a frame on the hole of the electrician box, then I insert it and I fix it with the screw, with the 2 screws. You see the screw here and here. I will do it with so you see the frame is installed, and you can rotate the frame a little bit over the long holes here, but I think for the demonstration so it's okay. And then the next step is what we have to do. You put the frame, the 55 to 55 millimeter frame over the metal frame, and then you use the device and you connect the KNX connector on the back side of the device. I do this. You see it's connected, and after you connected this, you can put this in the frame and it clamps over the metal clamps. So it's already installed. It's very easy, the installation. You can see this. And the installation is the same by all devices from the Cala series. Okay, then we switch back to the presentation. I think the next topic it's about the parameters from the Cala IL CO2.
At this point, I'm sorry to interrupt you. We have a comment from Sharma. He says parameters about pressure settings. That's a good thing. You are right, but we will make another video about it. Now Frederick shows us settings about the CO2 and especially the Cala IL. Not the pressure settings, but thank you for that. We will note it and make a separate video.
Okay, then we dive into the ETS. I prepared the project and I will share it with you. So here we see the ETS and we prepared it. In the left side you see the Cala IL CO2 and I go to the parameters. In the first topic you see the general settings. Here you can set how the device works after a reset or after a bus voltage reset. Here we can set a delay that for the transmission after a power on reset. The next topic it's about the indication light. Here we have some more parameters and I will explain you all these parameters. In the first two parameters we have to set how the device will work after a reset. The default setting is that the device starts with the switched on light and the brightness of the light it's 100%. Here in this choose we can decide from which objects the light want to be controlled. We can say the light should be controlled over the CO2 total measured value. It means that you can use the integrated CO2 sensor or you can mix the integrated CO2 sensor with a second sensor, and so you can use the mixed signal to switch the light from red, yellow and green. It's dependent of the CO2 measured value. Another option is that we use 3-bit objects to switch the light from red, yellow, green, or we can change the light colors over the scene objects, percent object, or 2 floating points objects. If we choose one of these, then we have different communication objects where we connect from outside the value to change the color of the display. But today we speak a lot of the CO2 and the VOC sensors and air quality. So for our part we want to use the CO2 measured value. I activate this. Here we can set if we, in this topic we can set if we want to use external communication objects that the last communicated value can be saved. And so it started after a power reset with the saved value, or we can say or set there that it's not saved. And here we can set the threshold for changing the colors of the device. So we see if we have a value which is lower 1000 ppm, then the LED is green, and is the 1000 ppm higher, also it's higher than 1000 ppm, then the display shows us a yellow light. And if the ppm value is higher than 1400 ppm, then the color changes to red, and we can change we can make our own settings there, but this is the default. And then we have a small hysteresis for changing the colors up and down, so that it's needed that the colors not flipped permanent between both or the two colors, for example. what we also can do, we can set what the LED should do. We can say the LED should flash, and then we can set the flash cycle, or we can say the LED should be permanent on, for example, or you can say the LED should be off, so if you want to only show green and red, for example. And then the last setting about the indicator light, it's the status objects. We can activate it here. And if we activate the objects, we have here 3 colors for each status object. You can say green, yellow and red, and you can change the colors for the status here. And with the status colors you can switch other RGB lamps if you want. That's all about the indicator light. And yes, we have a short look to the CO2 measured value. In these settings we can activate that the CO2 measured value which the device measured will be sent on the bus. I activate this here. I want to send the CO2 value on change and periodically on the bus, and then we can set here how often we want to send the cycle time. For example 10 seconds, but you can change this to minutes if you want. Then we have CO2 threshold values integrated in the device. You can use it, for example, to switch a window or to activate a ventilation system. And the threshold value you can set when you want to send a 1 or a 0 on the bus. So here it's the threshold set point. And here you can say what should be happened if the threshold is over, and what happened if the threshold minus hysteresis is below. And then we have short delay. For example, you can say it must be over for 5 seconds or must be less than the value for special minutes, and then you can close the window, for example, or deactivate the system. And you also have blocking objects. Yeah, that's all about the CO2 measurement. We also have integrated an CO2 PI control, but this is a very big topic, so it's too much for this webinar today. But with this PI control you can control an CO2 or the CO2 measurement and ventilation system, for example. Yeah, what the device also have, what's very new by our products, it's you can see our context tab. If you go to the indication light, for example, and click in a parameter, then you see here the texts, and in this texts you find informations about the settings. There's a short description for what is this parameter, and it helps a lot by the parameterization and by the setting of the device. Yeah, I want to give you a few seconds to write your questions in the chat, and then I will answer you the question, and I'll be back in a few seconds. Okay, then we jump back to the presentation. Okay, we are back. We are finished with the live demonstration and with the ETS. And so I jump to the next topic. It's about the application examples, and it's the topic of Martin.
So thank you, Frederick. As mentioned before, and I said, okay, we will have a closer look to it. As application examples for CO2 sensors in the first, I want to give some words about classrooms and lecture halls, because their high CO2 levels lead to tiredness, poor concentration and headaches, and a CO2 sensor enables automatic ventilation control to maintain learning performance and attention. Very high CO2 levels over a long period of time can lead to health problems. Very important. Okay, next thing is office and meeting rooms. CO2 levels rise quickly in meetings with many participants. Sensors detect this and control ventilation systems so that productivity does not suffer. Manual ventilation is rarely taken care of, you know it. And manual Therefore, it is important to set up automation. Next thing, living rooms and bedrooms. CO2 levels can rise sharply, especially at night in tightly insulated bedrooms. Sensors help to optimally control ventilation or window opening for a healthy, restful sleep. The next thing is smart building and energy management. Instead of ventilation according to rigid time specifications, ventilation systems can be controlled as required based on the actual CO2 values. This saves energy and costs. Okay, and now we move on to the application examples for VOC measurement and control. For example, new buildings or renovated rooms. As mentioned before, freshly painted walls, new carpets and furniture gases can release unpleasant odors as well as odorless but harmful substances. VOC sensors detect these emissions and can control the ventilation as required or signal the need. In schools and nurseries or kindergartens, children are more sensitive to pollutants in indoor air. VOC sensors help to detect contamination from cleaning agents or craft materials at an early stage. Homes with low air circulation, or for example cooking fumes, cigarette smoke and cleaning agents vapors build up, especially in modern airtight building. A VOC sensor detects the mixture and enables automatic ventilation. And the fourth thing is workplaces with chemicals. In laboratories, workshops or print shops, a VOC sensor detects vapors that could be harmful to people at an early stage. An automatic display or ventilation system is also necessary in medical areas where a lot of disinfectant cleaning agents are used. Okay, a few tips about how to ventilate properly. Most of you know it, but yes, it's always a good thing to say them. For example, ventilate the room several times a day for about 5 to 10 minutes, or use an automatic ventilation system. Cross ventilation for rapid air exchange is needed. Ventilate after moisture, for example, cooking, showering, and use CO2 detectors as an aid for correct ventilation. We gave you many examples before.
Okay, then we have a useful little helper, that's the Air Vision. I want to give you a short look on to the device. You see it in the picture. This device is a standalone device, it's without KNX, it's only with a power supply over USB. And you can put this on the power supply and you see the 3 colors, red, yellow and green. And with this color you can make a detection of the CO2 in the room. So it can be easy used in offices, hospitals or some other building in your living room, for example, because you often not know when is the air quality not good, and so you get an information when you should open the window, for example. I think it's a very little helper for all of us. Okay, then we are short before the end of the webinar today. If you have some more questions, then feel free to write in the chat. We will stay here for a few minutes and we'll answer all the questions for all, and we give you a short time to write us and then we are back to answer them.
Yep.
So we are in the end of the webinar. We get one question. I think the question should be for the Air Vision sensor. The question is how where we should install the Air Vision. The Air Vision should be installed next to the places, for example, for the table of your office place, or on the table in the meeting room, there where the person is sitting, for example. The best is you put the sensor not next to the window, because if you open the window, then the sensor get permanent the fresh air, and so they not can detect the not not best quality in the room. Okay, we see there are no more questions. So here on the last page you found our LinkedIn channels with the QR code. If you want, you can write us after the webinar, or you can write us an email if you have some more questions. And we hope you enjoy our webinar. And after the webinar you will get a feedback code, and with the feedback you can give us the feedback over the webinar, over the instructions of the webinar, and feel free to give us the feedback.
Okay, at this point I would say, okay, if there are no more questions, so let's close the webinar, and we are looking forward for the next one. Thank you.
Thank you for visiting.